Hello, everyone. Thanks those of you that made it today. This is sort of off day. We're doing on Wednesday, but I appreciate y'all making it. And those of you who can't, I hope you catch up on the video. Reach out, ask questions along the way. But we are back for Higher Labs Coding Bootcamp Week 2. We're talking about data structure. So we're going to talk more about structures. Really done a lot of those. We talk more about data types. Um, Today, day 4, we are working on evaluating the algorithms and data structures. And the theme for today is choices that we make and how we solve problems and what we do with the tools that we've gone over so far. So if you think about up to now, we talked about, I sent out this problem set. We're going to talk about this in a minute. Up to now, we've sent out and talked through basically the tools. Like if you imagine walking through a construction site or a shop where people are working on cars or something like an auto shop, we've literally been talking about the nuts and bolts and the hammers and the screws and the screwdrivers. That's what these variables and for loops and lists, that's what all these things are. The intent of the problem set was to give a structured way to start using those tools for something. Some of the purposes are a little bit contrived, arguably, but it is more of a practical to try to tie together the what and the how of we write these things with some sort of why. So I know some people mentioned on Discord, but does anybody here an opportunity to do a couple of these problems, worked on these, have any questions about the problem set specifically? I know there was one question on Discord, but I want to ask anybody here before we dive off into that.
I haven't gotten into them yet.
Okay. Okay. And that's totally fine. That's the other thing. I know normally we have a day between when I give them out and when we talk about it. And I know we haven't. So there's been a ton of time between last class and now. And there
Yeah.
also isn't a specific time frame within which you're expected to do those things. Like I was talking to Michael about this right before class.
Yeah.
We picked 20 because they're a good starting point to mess with. But there's like endless hours of those things. Even the free code camp that's at the top of the list of resources, even if you don't get into Code Wars and Leak Code, they have interview prep things that are just like this. Some of them might even be the exact same ones. So it's okay if you haven't got to them yet. That's totally fine. What I was going to do with part of this time, though, is address a question that, again, did come up. Hold on, there's one in chat. Certainly the problems today, that's totally cool. Alejandro, don't worry about that for all the same reasons. Actually, out of this, and before we go into the today's content, the review, and all that stuff, there was a request on Discord to kind of go on through the process and talk a little more about these kind of things, this code wars and the leak code that we sent out, and how we approach these, even, and what this is even doing, right? So I do want to is comfortable doing this and doesn't feel totally lost here, because the purpose of these is to solve the problem and reinforce the syntax of Python. But solving the problem is the focus, right? So start with that as the first thing you do. So what we're gonna do is we'll just walk through this, and we don't have to solve this one together, but I kind of want to show you the process by which, and I know I highlighted also in Discord some things in the free coding resource. If you like reading things, there's the programming explained. It's very good. It explains a process by which you can approach these sort of problems that we have on Code Wars and Leak Code. Also linked.
Which resource was that to like see how to approach it?
Yeah. So this has, we can even look at like
Okay.
really break down Python programming exercises gently explained is the name of it. And it's in the free coding
Okay.
resources. Guy explains, does a great job of breaking this down in these are actual exercises where he has code. Let's show this. This shows the, this is explain, right? So exercise description, solution design, special cases and gotcha, solution template. This is the that you approach these things. And that's really the value of this book. I absolutely encourage you to do it. Like look through this because he has specific examples of code. Like here's the exercise description, here's the solution design, broke down one by one exactly what step is going to be done, special cases and things like that. And then some sort of solution template that if you look at this, it's not really code. It's pseudocode, pseudocode, right? This is something you could write by hand on paper, on a whiteboard, the kind of thing that you'd be doing in an interview if asked to do one of these things at a coding interview, if you're gunning to be a coder developer after this course, further down the line, somewhere later, this is the kind of thing you're going to be able to have to do well, is this step-by-step process in this kind of context. So this is a really good way to approach it, and we can talk a little bit about it here. But really, generally, the key way to do this is on the left-hand side, and it'll say exactly what you need to do. So this one, very simply, to run, given a URL as a string, parses out just the domain name and returns it as a string. So the solution is going to go over here where it says solution. But before we even think about that, we don't even, again, we could grab a pen and paper, whiteboard, go somewhere else and think about how we would solve this problem, right? Think about what it is that we want to get out of here. They have an example of the kind of data that we're going to face, which URL shouldn't be weird. And the domain name is just this part of it. So like say github.other garbage, we just want it, right? This URL, we just want the zombie /byte or -bytes thing, right? So we just want the domain out of these strings. So we know we're dealing with strings, and we know we should be dealing with domain names. So we start thinking about like, all right, cool. So like, we shouldn't be worried about hash tables or lists, most likely probably just manipulating strings. And so then before we start thinking about Python specifically, how it does things with strings, we just think about like, all right, cool. So like, what are we going to do this thing? Let's walk through the process. Like, what's the first thing we might want to do if this was the first input? Like, just deal with one input. If this was the thing that we got, what might we want to do this first? Anybody? Throw something out. What might, if we are all get just GitHub out of this, do this whole string here first, try to get that out of there.
Can you repeat the question one more time? I'm sorry, I'm lagging a little bit on my end.
No worries. So yeah, just write a function that we given a URL as a string, parse out just the domain name, and return it as a string. Basically, the company name out of this, like GitHub is the domain name here. We have all this HTTP, which we'll talk about this if you're not familiar with what these are. We'll be very intimately familiar with this coming in the coming weeks. But we don't need any of this here. We just need this. We don't need the .com. We don't need the carbon5/regular. We don't need all that garbage. So what we're doing is
you need to define some kind of a variable that calls out that this is going to be GitHub, right?
So what you need to do is, basically you need to just slice up this string, you chop up and throw away the parts you don't want to keep and just return the name of this. So imagine a scenario in which you're keeping like a domain name registry or something like that. And you want just the names of the company's domain names that are unique to the place, because www is not unique to anything. We don't need to keep that in a list anywhere, right? So we might be dealing with hundreds of thousands of this, millions, who knows? On an automated way to chop off all the stuff we don't want on our string and save space in our database and just store like the company. Right? So we need some variable for that and to return it. But just think about the string itself. Like, what are the processes that we're going to want to do to this thing? Imagine this is
Probably
like
run through it like an array.
You could, yeah, okay. So you could, okay, that's one thing. And then do what? Like try to find a point at which you think the
Which
name
it starts matching. Yeah.
Okay, cool. So you could come up with some kind of matching thing to figure out, all right, cool. So we match, and then what would you match?
Just match up GitHub to your.
All right, cool. So then you have a list of like known things and you match them up to this. Yeah, cool. There you go. So that's exactly what I'm talking about. I'm not going to say that's right or wrong. I'm not going to say that's the best way to do it or anything, right? There are a million ways to skin this. We could chop up this string by all kinds of different methods.
What would be the best way to do it, though?
We'll get that. That's the entire theme of this course, man. There is no straight answer to that. It depends entirely on context and what you're trying to do, and there is no one answer to that, right? So,
okay.
The theme of today is how to answer that question, though. So it's a great question. There are better answers, and we can.
There gotta be.
Yeah, exactly. So, but again, we're going to talk about today how to decide, right? So, that's the process by which you formulate the approach, right? So I think we've done enough of that. We don't need to walk through actually solving this one. That's totally fine. Brian, your suggestion, I think there are some solutions here we can look at that are probably going to be approached that way. But once you have solved these, once you solve one of these platforms, the beauty of these things is that you can view the solutions of other people, right? So this one is solved. So I can come in and view the solutions and to see all the ways that this Code Wars community has huge. So there's all kinds of different ways that people approached it. This top one, in my opinion, is by far the sexiest one. This is nothing like the one I came up with. I came up with a couple of if blocks that do some kind of clunky stuff, but it solved the problem. My thing solved the problem. This is way
So
cool.
that guy's just like removing like the things he knows he doesn't need.
Yeah, so he's using this built-in
That makes
string
sense.
method, and he's taking stuff off he's just grabbing stuff from the back, and he's doing it all in one line, and that's just. And so this could be upvoted by best practices and clever, right? So again, these are good Pythonic ways of doing it, but right here is another totally acceptable way of doing it. It uses an imported package. So this is a module in Python for what's called regular expressions. If anyone's familiar with those, these are patterns for searching things. So Brian, this would be similar to what you're talking about. This might be one of the approaches you would use where you put in this is called a regular expression right here. And it checks the pattern of your URL, and then it pulls out, this section that you want out of it. This is a way to do it. It's totally different than the first one, but it's logically works, right? And then you keep going, and you can see there's just myriad ways of doing this, of solving this one problem. There's all of these, and all of these are valid. All these pass the tests. All these worked. Some of this one is like very explicitly, I think, probably being
He's got everything in there. He's
yeah,
covering
kind of
all
being
the
a pain in the
bases.
ass, being explicit, but that's okay. Like that's the solution to the problem. It works. If it works, it works. If they pass the tests that were built into this, then it's viable, right? So I guess actually,
So the thing I'm struggling with is I understand you got to break this down because that's why I said you need to define the string for the domain.
yep.
But what I was not aware of is what are the commands to use to help break this down? It seems like there are certain prefixes that are used, like url.split,
Yep.
and then something something,
Yep.
and that's like a command for Python that knows what to do, how to split that URL
Does.
up.
Yes, exactly. So
What I don't know is where you tell the URL what you want out of it.
mhm. So check this out. We can go back into that specific thing, but I want to show you this real quick on where you can find those things, those what's called methods, built-in functions in Python that make it so cool, right? That make it able to do these slick solutions. I was going to go back and show the test, but let's talk a little bit more about that. So this thing uses it's really common built-in string method in Python. Once you've thought through your logic, you're like, all right, cool. So we're dealing with strings. We're dealing with only strings. I mean, you just kind of forget about integers and floats and booleans, all that stuff. You don't need to worry about this right now. You're just doing strings. So what you could do would be like, all right, cool. So now I know I want to chop up a string and do some stuff with it. You just go to the Python documentation. This is linked to the sources. It's free online anywhere you put in Python documentation. But you come in here to Python docs. There's a whole bunch of stuff in here. Down on docs should take you where you want to be. And then if you just type in string, so then we have this string module. We got common string operations. Then there's a whole bunch. There's a glossary, doc strings, a whole bunch of stuff. This is the one we're looking for right here, just regular string. And if we click on this, we're like, there's string constants. That's not really what I want. String methods. That's what I'm looking for. Now, if you look
How
in
much
here,
of this are you allowed to use if you're like you're solving something for like let's say a job or something? Like,
all of it. This is Python.
can?
So again, this
'Cause
is
I struggle with that. There's a lot to remember with it, like syntax, and then you've got all the methods that go along with it. Like it's
don't
just so
think of it as
much.
stuff you need to remember. That's the thing. It's just
Yeah.
so in the 21st century, man, we don't need to memorize anything. We just need to memorize how to find it. Right.
Yeah.
So the majority of stuff that we use over, we know where to get it and where to look it up. Right. So I'm always in these documentation being like, man, I know there are cool string methods. Let's see what there are. There are things that can count what's in there. There are things that could do encoding, things that can find the suffix, right? There's just all
Yeah.
kinds of stuff. But there's formats. So we did this in a format. We did this with a formatted string with the F and the quotation marks, right? But so this to the question of like, how do we do this? And slice is somewhere on here, and split is somewhere on here, so you can see if things are lowercase and use all these things. So again, if you know that you're manipulating strings, you can come to the documentation and be like, all right, I need to check to see, and say another problem. I want to check to see if a string is uppercase. Cool. Well, there's one to do that. But let's look at what is split is what they're using here. So let's find split. Where is that pass already? Strip join. Split. There we go. So split. So there are a couple of different, oh, that's R split. Here's regular split. So we got string dot is meaning the generic string. So in our case, it's going to be URLs. But this is what split thing explained. So it says return of list of words. So it's a list in the string using sep. So that's this argument right here that we know is a keyword argument, but we can just put it in there as the delimiting string. So here are the examples of here's a string 1, 2, 3 dot split, and the comma passed as a string itself is the delimiter. It'll come back with a list of all of those parts of it broken up on the comma. So if we go back to the context of the problem we're trying to solve and the way this guy did it, he starts out by taking the URL, splitting it on the 2 slashes. So imagine what that does to the URL. It takes off all the .https and stuff and all that stuff that's in the front, all that colon stuff, and it takes out the 2 slashes too. It takes out the thing that is the delimiter as well, as you can see again in the documentation, right? These strings are just the number 2. There's no comma. This comma is part of the list, not the string.
Mhm.
So that's what he did here. He split this on there, and then he did the -1. We talked about you can get things out of lists by getting the last item by doing -1. So he just grabbed the end, doing -1, and then he split it again to make sure that there's no www, and he took the last part from there. So if there is no www, it doesn't do anything. It skips this part and still takes the last ending piece, and then it takes out any remaining and first part of that list that's returned. So it does split 3 times, and this should handle all of our test cases. So what I'm going to do is I'm going to copy and I'm going to find out. Because again, we've already solved this one. So this is one we could try out somebody else's solution, see if it works, right? So I'm going to go solutions. Wait, where's my train again button? There we go. Train again. So then it's reset, and I'm just gonna paste in that guy's solution because it was super slick. And now we can do these 2 buttons. There's test and there's attempt. Now, actually, first, before I do, I'm gonna take this back out. I'm gonna replace it with what was there. This word pass is kind of handy when you're filling things in. It's a reserved word that makes sure this doesn't break when you run it, but it doesn't. It just kind of like says there's a definition with nothing in it, and it will throw an error in like a syntax error. What I recommend you do though is you look at these test cases and you just run a test on it real fast to see what you get over here on the output, right? So it'll say, here's the result. It says none should equal Google, or, none, since we didn't do anything, should equal Google, right? So it'll tell you what you passed and what you failed. And here is the structure of those tests, like the input data is here and the expected result is here, right? So you can write your own, you can add these things, just copy and paste in this whole test assert and put in different cases if you want to. When you hit attempt, it's going to have even more cases than what's listed here. So it's in your best interest to add more if you can. But so let's run this guy's code and see if it passes all these tests. So we test, and it does. And so we can actually see, no, it doesn't show them in here unless you fail some of these tests. If you fail some of these tests, it'll show you the result in the thing. If you pass them, it's just say, cool, you passed all the tests. And then once you hit attempt, it'll say you passed those 2. So again, this solution works. And what he did was he just used the built-in split 3 times and then used the 0-indexed list capability at the end of the list over and over again, right? And again, this way sexier of a solution than I would have come up with. I didn't come up with anything that cool when I wrote this. My thing was just a couple of if logic things stuck together, and we're all happy with that. So let's make it how this is approached and what we can use for it, and how we find the different things that we can. Once we've honed in on what it is we're working with, strings, then we can go to the documentation and find out all the cool things that Python can do with strings and find the piece that we need. Does that kind of make sense as a process?
What was that
Yeah,
document
definitely.
reference? Was that doc.python.org?
Yeah. So this again,
Okay.
it's linked in the resources. It's just python.org/doc. This is the documentation there. But all in the free coding resources. You can hop into that.
Yep. Okay. Got it.
Cool. All right. So yeah, no, I encourage everybody really try out those things. And the difference between Code Wars and LeetCode is not massive. They're both generally doing the same thing. LeetCode tends to be more like getting ready for developing interviews, and they have a lot of code specific companies. If you're interested in like seeing what Facebook or Meta or whatever they call themselves is asking at code interviews, they have that kind of information there. So that's really cool. But that's the approach. That's how you approach these things. What other is how we make the decisions, how we decide what we decide, how we know what the best solution out of these things is. Because you see, there's all these millions of ways of doing it. So let's dive into that. Unless there are any questions about solving these problems further. No? Cool.
No.
All right. So I'm gonna go back to slide quick. So I do have a few things to go over today, not real long. We get kind of back into not exactly hands-on. We'll do one sort of coding thing, and then it's gonna be a lot more sort of theoretical. This will be kind of the more computer sciencey day that we're gonna do, probably the most one that we're gonna do. We're not gonna get real crazy deep, but to set the stage here, remember how we've talked about data so far. We've talked about data in two different ways. Well, actually, wait, languages first. Talk about data and languages, right? So we talk about the dichotomy between our English language that we're speaking right now and machine language that we're trying to communicate through these other languages, one or two of these other languages, into machine language. Is the balance that we're always trying to strike in everything we're doing. So all the decisions that we make, Brian, to your question, to everyone, like how do you decide what's best? This is really how you decide. There are two ways of looking at this, right? You have to say, okay, is it human readable, easy to maintain? Someone else can come in this project and know what's going on and contribute to it. Or is it just confusing and nobody knows what these variables mean and no one can follow it? If it wasn't me, then it's, it needs to be changed, right? And that's where PEP 8 is making it human readable. But the more you have human readability, the higher on this chart you are. Python is like the highest, closest to human language we've got, the harder it is for a machine to read. So there's a cost. It costs more machine power to break this down and interpret it into assembly language, machine language, any of these lower languages, right? So machine language, ultimately binary where it needs to be. So sometimes the most efficient, the best solution is the most efficient for the machine to understand. Sometimes that's the best solution. And we'll talk about how that's decided today. Again, to get there, though, we got to talk about data, again, real quick in the ways that we've talked about it. So we talked about it as being binary. Tommy, you got a question?
So with all those other languages, would you just have to learn all those syntaxes separately and see how they work together?
Yeah, you would, but you'll see as you pick up one and then you start to look at another, they're doing the exact same things in slightly different, not the exact same things, but broad, like most of the same stuff. Like everybody's got variables and they a little bit differently, may write them a little differently, but it's not going to be a huge departure, right? So getting the concepts down, yeah, you'll have to learn new syntax, you'll have to learn new pieces, and some languages are going to be easier because they're closer than others, but they're not as complex as learning it like a human language. Like if you speak English, it's not as hard as learning like Cantonese or something like that.
Copy.
Yeah, cool. So computer data, we talked about as being binary ones and zeros arranged in 8 sections as a byte, right? So this is going to be relevant again when we talk about what is being done by a computer to understand what we write. And when we talk about efficiency, this is relevant. These sections, this space that is being used in memory and in storage is relevant to what we talk about and when we talk about making our decision and choosing what we choose. We'll get concrete about that as we go, but this is one thing we got to remember as a review. The other thing we've talked about is data types in Python specifically, but these again are broadly applicable in a lot of ways. What data types does anybody remember that we talked about? Any data type.
Integers,
Yep.
string,
There we go. So we got our literals, those things, the strings, integers, your floats, your booleans, all those things that we can write as like a thing, right? Then we have the collections of things, as these are sort of my arbitrary groupings, but then we have got their variables that can hold strings, integers, floats, booleans, lists that can hold variables and the literals and lists, and then tuples, sets, and then things that provide functionality, right? So we got dictionaries, we got functionality, the functions, that's really the only one we've got that we've talked about. And then groupings of those in classes versus attributes and methods, which again, attributes are just like variables in the way that we write them. They're just inside of a class. And then functions and methods are basically written the same way, except methods are inside of classes and they always have a default reference to self because of the class thing. But other than that, so these are the data types we've talked about so far. So we've talked about data again in 2 different senses. We'll talk about it a lot in different meanings. Today we'll talk about how we choose which ones we choose, like why we choose a list over dictionary, those kind of things. I also want to remind you the underlying theme of this entire course as we go is that all the stuff we're doing is files and directories. So we wrote a basic program. We had in our /home/username our main.py file, and we invoked that by calling it different ways. all of this boiling down all these languages things, it's always going to be files and directories. So let's not lose sight of that as we talk about the decisions we're making and what we're doing, because that aspect of it, how things are read, the power it takes to do it, the time it takes to do it, those things are all relevant to it. So any questions about any of those things that we review? All right, cool. So when we talk about the choices we make,
Can you go back to that breakdown?
which one?
My question here is, no, well, I guess fine. Is when you start making functions, classes.
Yeah.
And then you do a, well, the define for, let's say, multiply A and B.
Right.
That's going to be a function, right?
Yes.
That's going to be stored somewhere in that breakdown, either a library or dev or home or something like that. Classes and functions, are they all built into a program like def multiply as an example? I'm trying to
Yes.
understand how the classes, functions, come together in that structure when you
Right.
build
Right.
out
And
a
that's,
program under main.
yeah, exactly. And that's the thing, is it's really your choice on which ones you're going to use. Like, so there's ways to use just all functions for it and never use classes at all. That's absolutely a possibility. There's a way where you
Okay.
focus on classes and use those exclusively. And as we build our web application over the next few weeks, we'll do exactly that. So we'll use these in a very practical application. That's why we build the app. So it's like, again, this is showing the tools. We're kind of show how to use them, and then we're going to really build something with it and really cement these together. So in the context of our web application, the functions there are going to serve the actual web pages. What it's going to do is it's going to go and find, we're going to write functions that are going to find a template for us that's a file in a directory somewhere that has some HTML on it, which is just a markup language that shows where things on the page are supposed to go. It finds that, and then it presents it out to a URL that we tell it to go to, so that the place that we tell it to go on the internet is what our functions are going to do. And so we're going to write over file, do that, and then at the end of the class, we're going to switch it over and write all those things over again in classes, show that there's a slight difference in what you have available to you by doing it, but you could do either one. And so these things they are the parts of every application that you look at. So like when we're on, say, what's Django, like or Airbnb, those things are built on Django, the Python framework that we're going to use to build it. And they're all going to have classes and functions to do all the things. So when you log in and when you open up a video or whatever it is you do on any application you do, when you reserve a place on Airbnb, those are going to be functions, or they could be classes. Does that kind of help answer your question?
I think so. I think
Okay.
this will become clearer to me and probably others as we start building these out
Yeah.
in our examples.
Yeah, and today we're going to try to use some more concrete examples. So we have talked about some, theoretical ideas. Like, these things are somewhat slippery still, but hopefully they will, to your point, become more concrete as we go through where they could be applied. Like, so as we talk about the decisions and the choices we make, right? When we get here and say the choices we make, it really depends on context. So it depends on what it is you're trying to do to decide what it is that you're gonna make. So it all is the problem you're solving. Like, again, if you're trying to get people to log in to a site, the choices you make, the way you do that, that's one way of there's one set of problems you're solving.
Yeah, looking at it from this perspective of starting from the ground up, everything looks like 52 cards pickup, but I think it'll start coming together.
It will. Yeah, it will. It will for a while. And the idea is, and again, I know that feeling, and that's what we're trying to help you get through, is the connected to the why. So if at any time you're like, I'm not getting the why of this, ask, and we'll spend time trying to make sure that we're clear on that. But some of it is just, hang on and we'll get there, I promise. But
Okay.
Cool.
Got it.
Cool. All right. So, and then similar to after I say all that, we're going to go through a really slippery concept and show an optional way of doing things. But this is going to help us illustrate these points and get more into it. Again, it's going to feel like we're just running through one confusing thing after another. Bear with me, man. Trust me. Like, we're all going to get there. So this idea of recursion, anybody know what this idea is already? Anybody run into this before? Heard it, seen it, talked about it? Know what it is?
I've heard of it, but I can't exactly remember what it is.
Yeah, it's a tricky one. It's one of my favorite ideas. I like it. It's really cool. It comes up in a number of different contexts, right? So it comes up in mathematics and linguistics, which is my world. And we actually do it all the time. We're doing it right now. It's something that makes human language. It's kind of one of the things that separates it from animal languages, even though not all human languages do it. But the way that we could take, say, sentences and endlessly make them longer. There's no limit to the length of a sentence. You know what I mean? So I could say like, I went to the store. That's a complete sentence. I can say I went to the store because I needed some milk. Those are two sentences stuck together. Now it's one sentence. I can say I heard that this guy went to the store because he needed some milk too, but then I went to the store because I needed some milk. And that's an even longer sentence. And we could just endlessly do this recursively, sticking things together. Tommy, what's up? You got a question?
So with this applying to code, that's how like, because like codes could be like pages and pages and like thousands of pages long.
We'll actually implement recursion really quickly and show what it does in code. And we'll talk about how it works. But the pages and pages of stuff, that's just because projects get like that. And we'll see that again starting next week, man. We're gonna have pages and pages of stuff in all kinds of different directories, and you're gonna be like, God damn, why do you keep track of all this for a simple ass application? That's kind of how it goes. It's just like all the directions you need to tell the computer to do the things you want it to do ends up being pages and pages and tons of directories. But yeah, recursion is a little separate from that. So that's one example of recursion in linguistics of sentences. The guys formal definition that we're going to see in the sense of computing is the repeated application of a rule, definition, or procedure to successive results. Right now, that is what we're doing too, and it's the same thing in math. Technically, I'm not going to pretend to be a mathematician, and again, we don't need to be. In coding, though, we're going to show how to implement this. The idea is just like repeatedly, referring back to itself. So this picture up here is an example of it's like an MC Escher drawing with the same pattern kind of locking into itself, and the end of one is sort of the beginning of another. That's one example. There's another. See, I think it's the last slide. So I want to show another cool example of this using this Google Meet. So this is going to be visual recursion. They call it the Forever Mirror, which I think is a funny name. But I'm going to start a meeting, and I'm going to share my screen, and this is going to be awesome because this is going to start a recursive. Don't need that. Oh. Okay. I got a permission to the camera again. Why can't I use my camera? All right, well, I don't need to. Boom, there we go. So now it says, hopefully it doesn't crash my internet. So if you can still hear me and I haven't frozen, you should be seeing my screen.
Yeah, we do.
Repeated a whole bunch of times, like endlessly down. And you may have seen this if you stood between two mirrors or something. Like this is recursion. This is the entirety of this thing, my whole screen, within itself a whole bunch of times, endlessly down. And this is sapping a ton of power. And the reason I said not to do this, because again, this can jam up our system. So we're gonna talk about recursion, why it jams up systems, and why we don't want to do this sort of thing. And it's going to be one of the things that we're going to see numerous times in ways people solve problems. We talk about the time to do things. So it's a concept we need to understand. Here, we don't need this anymore. We need to understand to really talk about like the decisions we make on what's efficient, what is taking course. Ace, you got a question?
Yes, sir. So just I may be going ahead, but
Sure.
For recursion, is the one of the reasons why it could jam up a system because it just uses a lot of memory?
It's exactly right. And that's what we're going to get to. It's exactly what it does. So we're going to implement recursion real quick and talk about exactly that, what it's doing and how it breaks things. And we will be able to differentiate that from what we've already loop that went on forever. So what we're going to do is we're going to go into our file. So I'm in my dashboard here at Python Anywhere. If you want to follow along, you can absolutely do this with me and implement this as well. It's very simple. It won't take a lot. It's not a lot of code. It's a couple of lines. And we're going to go into our main.py file where we have our while loop, if you remember, with our container filler. And I'm just going to go down here and I'm going to implement a recursive function that does the same thing, right? So I'm going to do a recursive filler that accomplishes the same thing, but it uses recursion to do it. So let's do our defining recursive filler. And we're gonna have a maximum for this again, just like we did before. So it has a container. Think about this, to remind everybody, we're rewriting this container filler code function that says we have a maximum size, a box that has a maximum size capacity, and we're going to put items into it one at a time until that capacity is met, until it's full, right? So we're rewriting that. We're going to use recursion to do it, but it's going to accomplish the same thing. I'm going to show you how it breaks differently, and that's where we're going with this. So unlike our container filler, our recursive filler is going to take two inputs. It's going to take the maximum, and then it's also going to take the count, right? So it's going to take the count that here we had on a separate line, and we initialize that to 0. This time we're not going to do that. We're just going to we're going to pass it in as one of the inputs. All right, so I'm in colon, indented block. Now I'm inside the scope of the recursive filling function. And what we do with recursive functions, we start with what's called a base case. So the base case is like the point at which we want this to stop, right? That's where we think of the end of the line that we want it to break and stop doing what it's doing. And to do that, we're going to check a logical condition to see if this condition is true. So we're just going to use an if control structure, the logical control structure if, and check to see if our count is equal to maximum, right? So it's two equal signs. Keep in mind, two equal signs. This is equal to. Don't use one equal sign, because one equal sign is assignment, and you'll be assigning things and it'll break on you, because if you try to do an assignment in a logical statement, it'll say, no, don't do that. So now I'm inside the if block, so I'm 2 indents over, and what I want to do is give the return value for our base case. So what do we think that is? What is the point at which we want this to break in our logical thing? Like, what are we trying to accomplish here? We're filling a box, right? So what's the base case? We can look up here for reference.
If count needs maximum, that's it, you're done.
Right. So then what do we want to give back that we know once we know we're done?
Either the number and end or something.
Sure, something. So we could just do this piece right here. The printing the container is full.
Yep.
Since we're refactoring that code, we can just take that thing and put it down here again. Say, all right, cool. Your container's full, man. You're done. Right? We could put the formatted string, say the maximum and things like that, make it pretty if we like. So that is our base case, though. That's all we need for it. We just check to see if our count is the same as our max. If it is, then we're done. We say, hey, it's full. We're good. Now we have to do the magic of the recursion is in the else statement. So the other case, right? So remember how this works. When we did this before, it's going to read this down to if and say, okay, I'm going to check to see if this is true. If it's not, it skips this line of code on 31, doesn't do this at all, comes to 32, and says, okay, else. So I'm definitely doing this. All right, so this is the recursive part. What we're going to do is we're going to call, again, I'm 2 indents over, so I'm two tabs or 8 spaces, and I'm just going to call the function that we were defining. So recursive underscore filler, whoop, except I won't misspell it, and I'll put in the same 2 inputs, the maximum, because that hasn't changed. The maximum box size, that should not change. That would be a problem if it did. But so that's going to stay the same, so we're going to pass that again. And this time we're going to pass our count, but 1 bigger than it was. So we are doing the increment of the count here instead of doing a separate someplace else like we did in the while. And we're just running the function all over again. So what this is going to do, and this is the fully formed function, this is recursive. This is it. This is the whole recursive function right here. We're done. We've written our recursive function. So what this is going to do when it reads through and actually executes this is going to check to see if the condition is met. And presumably it won't be the first time. We'll probably do a count of maybe 5 or something, or a count of 0, maximum of 5. So it won't meet the first time. So it'll come down here and it'll say, okay, cool. So let's call this again. So let's do this thing with our maximum of 5, our count of 0 plus 1. So that's 1. And what it's going to do is it's going to save this in memory, and it's going to add it to what's called the stack. I want to talk about what a stack is. It's a data structure, not a data type. So we're going to talk about data structures today. A stack is one we're going to talk about. It's relevant here, right? So it stacks this call onto our stack. A stack is a limited size of memory. And so it's going to run out of that memory. And it'll break it eventually and be like, all right, man, you're out. That's it. That's all we got. So now that we have this, let's save it, try playing around with it, and see if we can break it. Well, actually, we got to call it first. Let's call it before we try to actually do anything, because that won't work. So what we're going to do is I don't need this. So I'm going to comment out my car stuff. And in my app entry point down here, I'm going to call my recursive filler function. Actually, I'm going to call both because I want to try breaking these again, right? So our container filler, just kind of remember what we did or how this looks when it breaks. So we'll do our container filler with a maximum of 5. And we'll have that lined up for afterwards. And we'll do that to break it later, just to compare how these break. But let's call this to see if it works, first of all, if it works as expected. So I'm just going to copy and paste. Give my recursive filler. I'm going to do 5 with the initial count of 0. So it shouldn't be too long. We'll save that and we'll run it and see what we get. So this should do basically the same thing that we did before. It shouldn't do anything different. Except and print out the steps along the way, did we? We didn't add our little additional things in here that say, hey, we need to print out along the way what our count is. And if we want to do that, we can add it up. But that's not the purpose of this, right? So it did fill it up. What I want to do, though, is I want to show how this breaks differently than the container filler, right? So that ran through and it worked. We got all the way down to the container is full. We put the count in there to make sure we actually got 5 things. But let's break this and see how it goes. Right now, let's put in some like huge amount of input and see what it does. Whoop. Actually, to do this, I do want it to print out the things along the way so we can see it. So let's move this call up here and do the same increment we did before and do count plus equals 1. And then just call our count here. And then we could do this same block. Let's move it down so we get that output along the way. That's going to help us understand when we break, how it breaks. So let's save that, right? So what I've done is I've just moved this whole like count, plus 1, the increment. I moved it out of this call, right? I showed you the basic recursive function. You don't need to do all these things explicitly. This is to give us some output along the way to show that we're doing this and how long it takes to break. So I'm going to save it. Let's run it. And this time, so it printed out along the way, and you see it ran about 1,000 times and it broke around 993. And so it says recursion error, maximum recursion depth exceeded. So this is that stack. The recursion depth is talking about the stack, the space and memory that's set aside for this call, and it just went too far. And it wasn't able to hold it, all these, and it died. Now, if we do this with 5 again, with our output telling us updates along the way, it'll just show us the 1, 2, 3, 4, and so it does each step along the way, and it had enough memory to save all those calls and spit it back to us. To our container filler and break this again, like we did before. Say our while loops, and open our while loop, and remember we didn't increment this, and we never gave it a condition to leave. Then it reason. So this basically just tells you you're being rude and we're taking up everybody else's space. Right? I'm now not cooperating with me to break in that way. It's breaking in other ways. But the idea here is breaking in 2 different ways, right? So one is spending up all of our memory that's available for it, and the other one is saying, hey, you're being rude, and stop doing that. It won't give me that message anymore. But I think the point is hopefully clear. Is that understandable, folks? That this is breaking in 2 different ways. There we go. Your console is printed so much that's interfering with other users, and it has been closed. So we get how those 2 things are different. The while loop and recursion both can accomplish the same task, but they can break the computer in different ways. Are we tracking? Your questions? No? All right. Cool. So there is, again, the question of like what's right to do it. Sometimes recursion is the way you want to go. Sometimes a while loop's the way you want to go. So then how do you decide, right? So in our coding resources, I've referred to this thing a couple of times, but I'm going to refer to this book in particular a few times. One of my favorites, called The Timeless Way of Building. It's actually written by an architect who was talking about designing buildings and towns, but it's a cult classic in software development. It's very much for developing software. And one of the core ideas in there is something I really recommend you read. It takes like an hour if you just flip through the detailed table of contents, as it's called, and highlight that. We'll talk about this more a couple more times. But the really important concept here is designing a configuration within a context that allows conflicts to resolve themselves. And that's what we're trying to focus on here is the context in which we're making our decisions is going to be the pointer to which decision is the best to make and which one is right. Brian, is that helping answer your question a little bit? We're going to get more into it, but is that kind of teasing into it? Okay. All right. The PEP 8 that we've talked about in the past as our style guide is one way of doing it, right? So if we talk about how human readability needs to be attended to, that's your PEP 8 for Python. This is going to make things human readable. And if you look at this, if you haven't already, we'll open this up and just have a look at this. When it talks about the introduction, it says that it's a standard for making it human readable. And this right here, I swear I didn't rip this off from this guy, but the guy that invented Python says that code is read much more often than it's written. The goal of this PEP 8 is to get more readable. Readability counts as the whole goal here, is to make this human readable, right? Now, the other side of that, again, keep in mind that dichotomy between human readable means is at the expense of machine readable. The other way of measuring it that's very common is called the Big O cheat sheet. And I've got this linked in here, and this is our Big O cheat sheet. It is Big O notation. Anybody ever heard of Big O notation before? Anybody talk about this already? No?
I've heard of Big O.
Okay. Heard of it?
Same.
I've tried to use it a little bit.
Yeah. All right. So the O stands for Ordnung. It's a German word for orders of magnitude, right? And it's really just talking about how much computing power and storage space is needed to do the thing you're trying to do, is to solve the problem using your algorithm, using your instructions. So what we have here on this cheat sheet shows our Big O complexity chart. And this is on the left-hand side, we have operations that are going up. So the number of operations that are being done and the elements going across. So this is like inputs or things that those operations have to be done on. So as it goes up to the right, there are more elements. As it goes up, there are more operations. These black lines that are going across are different, what we call Big O time. So there's, we don't have to worry about it specifically. We're not going to be calculating Big O notation, but this is to understand how we make the decision. This is one of the reference points, or one of the ways when you're looking at, say, Code Wars and LeetCode, that people talk about their solutions. They'll say, here's my solution. Time complexity is O to the, it's linear time, and space complexity is something else, right? This is what they're talking about, right? So we don't need to worry about that. This O to the N with a little exclamation point is factorial time, and this is, polynomial time and exponential time. The main thing to remember is that anything that's in this red is horrible. This is terrible. This is really slow. We want to avoid this if we can. The orange is bad, yellow is fair. This little green slice down here in the bottom is good, and this darker green at the very bottom is excellent. So our goal in this Big O complexity thing is to get down here in this green area if we can. But also I want to highlight, well, first of all, before we go too deep in that all makes sense generally, like what we're even looking at here. Any questions about this?
The Big O notation.
You're breaking up, man. I can't quite hear the question.
How important is it to learn it if you're looking to be a developer?
Great question. Absolutely crucial. You're going to have to know this for sure. So it's talking about when you go to solve this problem, you're doing the LeetCode and you're doing the Code Wars things. LeetCode in particular has more stringent complexity requirements to pass their code. Like you can kind of get by with some squishier stuff in Code Wars. And when you go to do an interview, you will be frequently asked, like you'll have to solve a problem exactly like on LeetCode and Code Wars, but just you do it on a whiteboard or something like that. And then they'll want you to know what it is. So you have to be able to know how to calculate it, which we're not going to go over in this class, but it's worth knowing if you want to get down there. They're also going to ask you if it could be better, like if you could do better, right? So you're going to have to know. So sometimes the first solution comes on the spot, like I said, the first one I came up with is probably way jankier than what I would do if I thought about it a little bit more. And so this is how you would talk about it, right? So it's absolutely crucial.
All right.
But beyond that, then beyond this part right here is we can use this basically as a tool to decide what data structure we're going to use to solve the problem that we have at hand, right? So here's a list of data structures. We talked about a couple of these already. We want to talk about 2 more of them in a little more detail. But so we got arrays, which again, anybody remember what arrays are in Python?
Yes.
What are they called in Python?
What was that?
What are they called in Python? What are arrays in Python called? It's a list.
A list. That's right.
List. Yeah. In general computing terms, it's called arrays. In JavaScript, I think it's called arrays. In Python, we call them lists. Lists or arrays. And then we're going to talk about stacks and queues. So we've already talked about stack a little bit in the sense of recursive functions. That's what breaks in the memory is a stack. And we're going to talk about that as a data structure that you might want to use and why you want to use it, and compare these 3 today to talk about how those things work. But again, looking at this chart, it depends, I guess, taking a step back, the data structure name was over here on the left, and then you have time complexity. This is how long it's taking to do the operation. And the space complexity is about the storage of the memory. So how much storage and memory is taking. And this all, again, in terms of ones and zeros, bits and bytes. And that's how we have to think of it. So it's usually listed in the average and worst case scenarios, and think about what that means being small and large, right? So one thing I want to highlight on this is when we're talking about these, if you're not looking to be a developer and you're just learning to do this to have the skills and supplement, and you're working on small projects, if you're on this side of the chart with a low number of inputs, it doesn't really matter all that much what you're using. Even if you don't use the most efficient thing, you'll probably be fine. If you start getting over to like the size of, YouTube's users base or something, then it's really critical what you're using, right? So the size and scale of the project you're working on is relevant to these calculations. But we can see here, under worst case scenarios, we'll talk a little more about what those are reflecting. It talks about specific functions that you're trying to do with it, like access, search, insertion, deletion, and they perform differently depending on what you're doing, right? So we'll talk about it's all relative to exactly the problem you're trying to solve, what choice you make. And there are a whole bunch of tools to do it, right? So let's do, maybe a little quick example of one of these. Well, we got some time before we get to the end, and we'll talk about this through some kind of more hands-on things if you want to follow along. We're gonna go back into our Python Anywhere, and we're gonna go into a Bash console. So I'm gonna get out of this. Let's go back to my consoles. I'm going to a Bash console. Cool. And then actually, I'm going to go by way of Bash into Python, into my Python console, because we're going to write directly in Python, and I don't want to deal with a file on top of me. So I'm going to do Python 3 just by itself. It should take me back into my now Python shell. And so now I can write in Python, and I want to show a couple of what strings or what lists can do when we add things to them. And I want to just talk about that a little bit more and show it once more, and then we'll talk about stacks and queues as a comparison to this, and why they might be different, why you might use them in different places, right? So if you remember a list, we'll just make a list and we'll save it with a few things in it. We'll say our list has strings A, B, and C. So it's 3 strings separated by commas in square brackets, and I'm assigning it to a variable A, right? So this is all I'm doing is saving this list so I can reference this list and do things with it. If you recall, we talked briefly about adding things to the back and taking it off the back. Those are built-in methods, and we'll show those in a second. But I want you to, before we do that, think about what this is. This is a named space in memory. When we saved it here, we called it A, and we gave it this size. And we save it as an array or a list in Python. That size is generally kind of fixed. So these things can change, but when we do one of those operations, either pop, as it's called, so A dot pop, open and close parentheses, this will pull off the last item out of the list and just return it. And so now it's not there anymore. It pulled it off and it's gone. So now our list is different size. This is the same list, right? And we can add things by doing append, right? So we could do append. We could put that letter C right back on, and it'll go in the back. So when we list this off, now we have all 3 of our things again, right? Now when we do this, to a certain extent, it'll be exactly where it is in memory, and that's okay. But if we go out of a certain size limit that's pretty tight, the computer is going to pick up this entire thing out of where it is in memory and move it someplace else that's going to be able to accommodate the other space. So if we add a whole bunch of stuff to the back of this, it's going to have to do that operation maybe a bunch of times. It might have to pick stuff up and move it a bunch of times. And that operation of picking up this whole list and moving it to another place in memory, because this has to be stored what's called contiguously, all in one space in memory, that motion is caught. So if you have an application that's going to be adding things to the back of the list, taking things off the back of the list, and you have a lot of inputs, this may not be the best way to do it. You may want to use another data structure. So this is, again, possibly with lists. Let's talk about stacks and queues and how they work to say how this is like another option that will be more efficient given a certain set of things you're trying to accomplish. Right. So let's keep in mind this example of Polynesian. And pending any questions though before we move on about the main thing I'm trying to get us to think about here is the contiguous nature of a list that needs to be moved in memory if too many things are added to it. That makes sense?
Yeah.
Cool. All right. Now when we go back to my main.py, I'm just going to write some things in text. We're not going to implement stacks of queues. It just takes too long, and it'd ultimately be somewhat uninteresting. There's not a whole lot of really interesting stuff for us to look at in doing that. So I'm just going to write these in as comments in text just for us to look at it, and it will be a little bit easier to write here than over in my column. But so let's talk about queues first, right? So talk about what a queue is and how you might want to use one and why it might be the best thing for the job. So a queue is, think about a movie theater, right? So we got a movie theater and it's got double doors and they're closed. And let's imagine there's a line formed outside here where there's one person here and then there's another person in that line behind them and so on and so forth with several people in the line, right? And I'm gonna put this in as a list, right? We'll call this a list for now because again, we could do this in a list. But a queue will be a slightly different way of doing it because in this case, we know that once these doors open, people are going to come in here and the first person is going to come out of this list and they're going to go into the movie theater. And then person 2 is going to come in. And as other people come in and want to see this movie, they're going to come into this side of the list. So they're going to come in the back and then they'll leave the front, right? So this is going to be called NQ, Q-U-E-U-E, too many E's and U's. U-E. UE, good God. And this is called DQ. So this is leaving and entering the queue. UE, DQ. And this is called a first in, first out structure. So this sort of thing, if we're talking about context of an application, if you're doing something that's relevant when someone showed up relative to another person, like say customer service, when somebody comes in and asks for a raise a customer service ticket, the time that they did that is going to be relevant. So you may want to have a timestamp on that. You want to use a queue to add them to a queue so that the customer service agents can pull the first person off and DQ the and into that. And this queue size can change, adding things to the front and back. And so if we tell the computer ahead of time, like, hey man, since we're going to be doing this, we know people know people are going to the other side of this thing. Instead of adding stuff to the front of a list and taking, adding stuff to the back of the list, adding stuff to the front and taking stuff out of and moving that whole list around in memory a bunch of times, treat this as what's called a queue and give it a variable space in memory that's more flexible than a list. And that'll help us solve that problem of picking up an entire list and moving it. So does that make sense why you may want to use a queue for a certain function instead of a list?
Yeah, that makes sense.
Anybody got questions about that? Is that anybody questions about queue versus
Just the
list?
first in, first out that makes it better.
Yeah, for that specific thing, right? So if you're
Okay.
doing ticketing system, customer service system, this is the kind of thing you might want to do. You might want to use a list to do it or a queue to do it instead of a list. But again, if you have a very small customer service system, use a list because you can get this. You don't have to, right? It's going to be back to this big O chart. How many inputs do you expect? If you're running a small project like Hired Labs, it doesn't really matter. We don't have hundreds of millions of people trying to access our site. We're not Meta. But Meta,
Yeah.
probably Meta. Like customer service, they've probably got a whole bunch of people coming in, right? So they're probably using queues. Cool. All right, so the other one that I want to illustrate, talk about a little bit, is stack. We talked about this already. Whoa, stack. And this is somewhat similar in that it can be done with a list, right? And the things that we've done before, if we imagine, so the pop and append would be useful for this on a list. But if we imagine, say, like plates stacked up, so there's a plate here, there's a plate here, they don't have numbers because they're all the same and it doesn't matter. I'm gonna do this left to right because it's just easier to write, but it could be vertical if you want to think about it that way. If it's easier to think of a stack vertically, like pancakes on top, you make them, you put them continuing on the top, and you just take one off the top. It doesn't matter what one's as good as the next. Doesn't matter when they got there. So I like this plate thing because imagine one side there's a restaurant and one side there's somebody washing the dishes, right? That's adding plates to the stack, and then on the other side, or on the same side, there's somebody taking them off, like say a line cook or something like that, that's actually using those plates to make dishes and send them off to the restaurant where they're going to be used and come back, cycling back in, right? So this is a stack where things are coming off of one side. And so this is the last in, first out setup. This is a different approach to something that, again, it could be accomplished with an array, but if you know you're going to have a whole bunch of things coming in and out, it's going to move that thing around, you might want to do stack instead. So stack is where we saw with the recursive function, all of our function calls, variables, and all those things use a stack as the data structure to accomplish all those tasks. So it's good to know what it does. And in a concrete sense, if you want to write, say, an undo function in a text editor, right? So the Control Z, I hit Control Z on here, and it removed the IFO in the parentheses. That was a stack. Those were the keystrokes that were saved in the stack. I hit Control Z and it pulled them back. So they used a stack to get that done. So that's a concrete example of why data structure. Any questions about that?
Makes sense.
Cool. And so those are also some real life examples of like why you choose one over the other. They can be accomplished with lists. All can be accomplished with lists. And ultimately what you're going to decide is like, how many it's going to take me? How much compute power, how much space is this all going to take? Is that relevant to me? Right? All right, cool. Any questions about any of that before we move on?
Not that I can think of.
Nothing from you? Anybody else?
Yeah.
Cool.
Well, a ton of questions. It's just not now.
Okay. All right.
Well, because we're talking in small amounts, but you start getting into the web page design or in applications, this stuff is going to be very, very important, if not critical, in how you handle the type of data that you're going to be dealing with, whether
Exactly.
it's large or small.
Right.
So lists are going to be good for, let's say, for our homework work, but when we start dealing with large amounts of data, digital data, metadata, we're looking at stacks, queues, arrays, and others, I think.
Yeah, absolutely. And that's the other thing. We're barely scratching the surface on all the. Yeah, Tommy, what's the question?
That's why I said hold my question.
Okay. Yeah. Sure.
Well, I'm just thinking of the example when like when a new website launches and a bunch of people come into it, it crashes.
Mhm.
So it's just because they didn't accommodate all of these like structures in the first place, or they didn't expect that many people to come in.
Yeah. So I mean, it could be a number of things, right? And something like to Michael's point, when you get to even a simple web app that we're going to do, it's way more complicated than these one really specific functional examples that we're talking about, like an undo function or something like that. So if a website crashes, usually that means their server got overloaded. It's probably not something now, but it could be something as simple as this. Depends what the crash is and like how bad the break is. You know, sometimes it could be as simple as it just tapped out the memory because they should have been using queues someplace that they were using lists instead. You know, it could be down to this level. That's absolutely possible, but it's probably more likely a network type thing or a server specifically being overloaded.
So there are instances where like it was like a small mistake that could have caused a crash.
Oh, totally. Yeah. And, you know, it'll be like something stupid like a misspelling or something like that too is going to be the kind of thing that causes crashes. So, but this is, you know, to Michael's point, when you start designing things, you got to think about the data that you're going to be dealing with flowing through your system and how it's going to transform and what structures it should be going through and being stored as and manipulated as, in those senses of like, okay, what's the most efficient way to do this? Because yeah, what if we do get a whole ton of inputs? We can't be lazy about it and be like, it doesn't really matter. You know, I say it doesn't matter because I don't want you to get too wrapped around on this if this is slippery for you. And since we're not going to be going through what our big O notation is and optimizing for things, it's not a very first basic thing that you need to spend a ton of time doing at the basic level when you're really learning the syntax and whatnot. But you do have to be aware that there are really tons of ways to do these things, and they are impactful, the choices you make, even on these small things, to Michael's point.
Okay.
Does that help?
Yeah, that helps.
Cool. And then so, and again, we only talked about array stacks and queues, and I want to talk a little bit more about algorithms before we wrap up today. So we're not going to even get into like linked lists and all, just lists. Hash tables also are really cool. They're really useful, and we've talked about them a little bit. What are hash tables? They're key value pairs. What in Python is a key value pair? Anybody?
Is it a dictionary?
Dictionary. That's it. So dictionaries, key value pairs. Generally speaking, they'll be called hash tables. You'll see them all over the place, and they're going to be faster, certain. Again, depending on what it is you're trying to do. I'm gonna come back to that here in a minute. We're not even going to talk about trees as a structure. Those are incredibly cool, and there's all kinds of stuff that is definitely worth knowing about those. I recommend looking at binary search trees if you're looking to learn any of these algorithms or any of these data structures. I think you'd probably be really good to start with those, understand array stacks, queues, and lists generally, but hash tables and binary search trees are going to be really useful too, right? We're not going to cover those in the course, but there's resources here to study these. And I want to talk a little bit about algorithms too, because there's some interesting things in algorithms that are very similar. So these could be thought of in the same way with big O notation. And we talked about algorithms before, and we talked about it in the really general sense of like, it's, got finiteness and it's for a specific purpose and all that thing. You will also hear people talk about algorithms in this sense, where it is a specific algorithm with a name for a specific purpose. So this list here shows array sorting algorithms. So this is just sorting arrays. It's not doing anything. It's like tons of other algorithms that you could do out there. And look how many there are. It's ridiculous. Just a ton. This is not comprehensive either. There's all kinds of ways to do this. But these have a name. So there's a quick sort. There's a specific way of doing this. And what's cool about this is if you click on any of these, just click on these names, it'll take you to this Wikipedia page, which is awesome because it's got a full explanation of what quicksort is. But my favorite part is over here. This little thing has got just like a GIF that shows how this is doing what it's doing. So it's a way to visualize what this sorting algorithm is doing and how the list is being sorted. So you think about this as a list or an array with all these items in it. This is what quicksort is doing. It's taking these things in these chunks and doing it in this way, right? So this is a cool resource to learn these things and understand them. And look, a ton of different ways to approach this, and they all have different, again, time implications. And these are just sorting arrays or algorithms rather.
Where would we find like a full list of like algorithms?
Oh man, I don't know
Just like all of them.
if there really is such a thing, because there's so many different ones out there. I
Yeah.
I would probably be better worth your time. Like you could see if there's something
Like
online
most
somewhere,
used
and
or something.
maybe resources. There's a link out to this it's like a Reddit thing that's got even more of this kind of stuff, just free resources and stuff. There might be something on there that's got a more extensive list, or you could just search something up because there's so many of them. I think it would probably be better to like focus on a couple and really understand, know what they are, know how to use them, kind of thing, or know what they do.
Yeah.
Right. So like out of these, the quick sort, merge sort, and bubble sort seem to be ones that people talk about a lot. So I think those three would be worth knowing out of this list. But
Okay.
but I mean, you could just spend your time learning sorting algorithms. Another one that's really common that I want to talk about, like some ones that are useful to know and to understand the difference. I'm going to go back here to go more text sort of explanation without implementing any of this stuff, is search algorithm. So search algorithms are very commonly discussed, and there's some good things to know in there, like how they work, which ones there are that are named or frequently discussed, and kind of some big ones, then stuff that you're going to run into frequently out there with these algorithms. So the first one is called linear search. And this is very, very, very slow. This is one of the slowest ways to search for anything. So if you imagine searching in a list or in a dictionary or something like that, linear search is going to look through, let's take an array. It's going to look through each item in that array one at a time and see if the thing that it's looking at is the thing you're looking for. It's going to match each one all the way through. The reason this is crazy slow is because its best case scenario is the thing you're looking for is the very first item in your list. The worst case scenario is it's not in your list and your list is gigantic. So let's say it's 1 million items in your list and the thing you're looking for is not even in there. So it's going to run through every single one of those 1 million things before it knows for sure that it's not there. That's really slow. So that's one way to do it. Sometimes linear search is the best way to do it, but just keep in mind that if you're doing some kind of for loop kind of thing, this goes back to anybody that wants to be a professional developer, a for loop is not an efficient loop. It's really inefficient. It's very good for like beginning learning stuff. But if you go into it, and this is, a good friend of mine who's a manager and does all kinds of coding interviews. I was talking to about this one time. He said, look, man, if you come to me with something, you better be better than a for loop. So this is great to get started with, but you got to understand it's not the most efficient way to do it, and it can lead to really slow stuff. So again, linear search, it's possible, but be careful with it. It's very, very slow. Another very common type of search algorithm is called binary search. This is a little bit faster, but it's not crazy fast. I'm going to like blow your hair back or nothing. Binary search takes your list. Let's imagine we got a list and we're looking for something in that list, and it splits it in half. And it basically says at each point, says, okay, cool. Is the thing you're looking for in the first half? Is it in the second half? And the way it does that is a really common, we've already actually used it ourselves up here in this for loop, which again, I told you is terrible, but this built-in in function, this checks for membership. Very common thing in computer science, not specific to Python. I remember I told you that sets are optimized for this sort of things. They could see thing is in there. It won't tell you where it is because it doesn't matter. Sets are not ordered, but it can just see that it's in there. It's a really quick operation, right? So binary search leverages that. So it just uses in to say, okay, is it in this first half? Is it in the second half? And the analogy I like to use, even though it's a really antiquated analogy, is if anyone's ever used at this point a paper dictionary to look up a word, right? So I probably haven't used one for like 20 years, but if you imagine a paper dictionary, right? It's A to Z in English, and the word you're looking for is in the first half of the dictionary. You're going to like open up roughly in the middle and then maybe bracket it in. I don't know if we got any Mortarman or anything like that on the call, but you kind of bracket into where you want to be by taking chunks and sort of sliding it down until you have smaller and smaller pages that your numbers of pages you're flipping through until you find the thing you're looking for. That's what binary search is doing. It's going to every time it goes through, every iteration it goes through, it's going to take half of your data set and just look to see if your thing is in there. So it's a lot faster than linear search. It doesn't have to look at everything. It's each time it looks at a smaller and smaller subset of your data. Then the last one I want to talk about as a just like a searching way to do it is hashing. And this is going back to hash tables. This is one of the faster ways to do it. It's even faster. I put fastest here out of the three we're talking about. I'm not saying it's the absolute fastest thing, but this is way faster for searching. So this is why like dictionaries are really good at if you know that you want to just like look something up, because you can just grab it by its key. You don't have to look at each item in there. Now this may seem kind of confusing. You may be thinking, well, wait a minute. If I got a whole bunch of keys, how does it not have to check the other keys to know that it's not that key? How does it just grab the right key right away, right? It's kind of a trick. When the hashing, right? So it's dictionaries in Python, but hashing in general is when it takes that key value pair, it takes the key that you assign, and it puts it in a list, basically. It gives it an index. So it has a known index. It knows where that place is. It puts it in a place. So all you got to do is reference it from that place, and you can go to it every time and get it quicker. So this is more like a modern, if you go on Google and type in the definition of a word, instead of looking at a paper dictionary, old school, this is more like what it's doing. It just goes to that single word. I'm not saying that's what Google's doing with looking stuff up. It does something more complicated than that, but hashing is a good way to that's a good analogy for hashing, that it grabs just that word you need and gives it to you. You don't have to flip through, hundreds of pages of a dictionary. Any questions about this concept? This all making sense about search algorithms?
Yeah, it makes sense.
Any questions? Right. And so the last thing that I want to talk about, just kind of touch on, is as a version of hash tables that you are probably going to see and use if you haven't run into them already. For those of you that are really new to this, it's something that I want you to be aware of called JSON. So JavaScript notation. It is a hash table. It's key value pairs in curly brackets, just like our Python dictionary. And it's a standard in web things and systems generally, like outside of just web stuff. In some data systems, data transfer from one system to another is often done with a JSON file. So being able to use and interact with JSON is something that you're going to do a lot of. It's very useful for moving information from one place to another. It's very efficient and good structure. So this is a term you may see around, and just keep in mind that it is a hash table. Like JSON is a hash table, so you know the structure of it. You can read a JSON file if you found one, if you needed to get one. And we'll talk more about it when we talk about APIs if we got time. Any questions about any of those things that we covered today or anything up to this point at all?
Would you say the algorithms is what you need to solve those problems, like on Leak Code and Code Wars? Like, if you knew the algorithms, you could like break it down from what it's saying and apply an algorithm to it?
Maybe you might find a specific spot where you're like, oh, they want me to sort something. I know a good way to do that. Or,
Yeah.
whatever the case may be. It might be. It might be one of these named algorithms or something. But, depending on the thing. At the beginning parts, you're really just writing your own algorithms in the simplest sense that we're talking about. You're probably not going to use any of the, you're probably not be doing any like bubble search or anything like that in the very beginning challenges.
I gotcha.
All right. Cool. So if there are no questions, I'm just going to say this to keep it. But those are the things that I really want to cover today, was make sure that we about some choices we're making, because there's a ton of different options to do things. I want to show you that there are no just specific right ways. It really depends on the content, what it is you're trying to accomplish. And then we talk specific ways that we might apply these things, like customer service queue, using a queue instead of a list, depending on your time constraints and how many users you expect to have, or using stacks if you want to do things like undo and backspace and those sorts of things. So next week, what we're going to do, we got some time between now and then. So between now and then, keep those algorithm problem sets that we sent out. Keep studying those things, looking at the syntax of Python through the free and that Python is for everyone series in particular. That's great for explanations of all these things. But practice. Write as much as you can, read as much as you can, do those problems as best you can. When we come in next week, we're going to start building our web application, and I wanted to show you, I spun this up really quick before class. I want to show you a real quick preview of what it is we're going to build, just so that we all know. So once we have our app up and running, it's going to be a really basic website. This is not a design course to make front ends look beautiful. This is to show the mechanics of how to set these things up, focused on the actual functional interactions. But we're going to use Django to build a site that looks like this. We're going to have some basic navigation. We'll get some, GIFs from other places and to make our content, connect things from other spots, show how to do that. Our application could be on one page, but we're going to do multiple just to show how to route the URLs. Our application is going to be a to-do list, right? And the reason we do a to-do list is every application you interact with can be thought of in terms that the function here, where you create something, you read things, one or more things, you update one or more things, and you delete one or more things. Read, update, and delete operations are really what all of our applications, even if we think about Zoom, the interactions that we have here, you're creating, say, if I got in chat and said something, I want to create that chat message and I want to send it. And maybe you can edit that chat message. And maybe you could delete that chat message. There's all kinds of those interactions are going to be what every application we're doing does. And a to-do list is a very simple example of that, right? So we're going to be able to add tasks in this really simple built-in form. So just, something aspirational. We'll give ourselves some time to do it. Give ourselves a deadline. then we can save it. So then we can see this now. Now we're reading our task that we've saved into a database someplace. We're going to talk about the database interactions and where that is and how we're interacting with that. Then we can update this and see the information here. We can give ourselves some more time if we want to. Say we need a lot more time to get our stuff together. And now it'll update that due date. And then we can delete those operations. And we'll use a little JavaScript here to pop up and say, hey, you sure you want to do that? And this is just kind of showing where JavaScript might fit into these things. We'll also show how you could accomplish this without using any JavaScript at all. But since we're doing a web application, it seems appropriate to acknowledge the language that's really built for the web. JavaScript is really for that. So we'll talk a little bit about it, where it fits in and how you might use it in combination with Django, which again is written mostly in Python. Once we hit OK on that, we should delete our to-do list item. And this is what we're going to be building starting next week. So we're going to lay the foundation over the next few weeks. We will have this thing completely built. Any questions, thoughts, or anything before we wrap up for today?
Not that I can think of. What did you have on your home screen with all that binary?
This is just some generic thing from Giphy. We'll go to this and show how to plug this in from a site, so it just has something to look at.
I saw that stuff coming in, and I was like, "That's crazy."
Yeah. No, we're not going to do anything this complicated. You should be reading this by now. If you're not reading this binary, if you don't understand what this is saying to you, then you failed the class. But any questions though? Anybody have anything for the group or stuck somewhere? All right, cool. So then we can wrap a few minutes early. That's fine. I'll hang out till everyone's offline, but keep practicing, reach out with questions. And if nothing else, I'll see you Tuesday.
All right. Sounds good. Have a good one, Jeff.
Yep. Thanks.
Thanks a lot.
Yep. Thank you.
I have a couple questions.
Shoot.
Okay, so I didn't get to, I had to miss yesterday's for like a different appointment, so I have to probably watch that. I have to rewatch that this weekend. So if
Okay.
I kind of watch the last couple courses, can I kind of like basically catch up before Tuesday?
Yeah, absolutely. So like what we did last time was well, here, I mean, I can even show you. We build kind of progressively each day. So honestly, you don't really have to at this point. If you want to just not do anything and just watch this, we're going to start building this thing like from scratch. So everybody's going to be at like the same starting point come Tuesday, right?
So was the Tuesday more a conceptual kind of day than actual like?
No, we were hands-on. Last Tuesday, we were more hands than we were today. So like, I can show you what we did, and definitely it's worth watching. It's worth getting a sense. Where's my actual damn Python anywhere? Hold on. Let me get back into this. So I can show you what we did, and it's absolutely worth watching. But again, as far as like, catching up or something like that, we're not going to build off of these specific files anymore. So if you don't get fully caught up by Tuesday on the files themselves, don't stress about that part. Is my point, because when we go to build the app, we're all starting on Tuesday with that piece, so it's going to be like fresh start for everybody. But we did this thing where we talked about our if construction, and we talked about loops, and we did this that we refactored today. So there's a number of things we did talk about that are really useful that you should definitely go through.
Yeah, because I remember I did Code Academy back in like 2016, and this is like the
Okay.
first few chapters before I fell off. So I feel like that's like the consistency is like, okay, like you don't really, I feel like they teach you these things, but they don't really like help you apply it and like what's like the point of it.
That's the problem. Yeah, man. It's like when my whole like coding journey, I was working at a startup that does data analytics, and it was a small company. I was like the 100th person that worked there. So it's, all the engineers, everybody was in the kitchen or whatever, and we're getting coffee. I was talking to this guy because I was curious, like how much like human languages, because I'm a language nerd, are these I kept hearing about programming languages, right? And he didn't have an answer because he didn't really know what I was asking, but he said, I just learned Python. And I'm like, all right, cool. So I went and I learned Python, and I got through all the syntax of it. Like they're talking about classes and functions and loops and all that stuff. And I'm like, cool. And I kept thinking, why are we doing this? We'll get to the why, right? And it never happened. So I had to go all the way back and figure all this context stuff out on my own. It's really hard to find things that teach all that stuff together, right? But that's really what we're trying to get here too, is like, it's more important to know where it is, kind of what it is, and then build something with it so we understand it in context.
Okay.
So yeah, go ahead.
I was kind of curious because a lot of these languages, they kind of just tell you what to do, but like, I feel like what, I know we'll never go into that level of depth of like, how did these like creators of these languages got to these like, I'm not like how I would phrase this, but like the people who develop Python and JavaScript, how did
Yeah.
they actually come to this conclusion? Like, this is the way this language is going to be written. But I
Yeah.
feel like that's too in depth for us to actually go into. Because I'm kind
Cover
of just
that.
I'm just kind of a
Yeah.
little curious and like just like, oh, that'd be cool. Because
Yeah.
if I kind of figured out that basis, can I actually use that to learn other languages and just understand coding at to what it is in itself?
Total. And the thing that this is kind of a good place to start this whole you know proposals for improvement, whatever this PEP 8 thing, this style guide, because this guy Guido, his name of the guy that he's like the guy that programs. So people did actually make these things. There is a history that you're talking about. There's a reason that they did this, and it is quite literally like, hey, all this stuff that's out there is too hard to read, and nobody can read it or whatever, right? So that would be useful. And again, it's also you'll get into the depth of like, I talk about integers in this course, and that Python can use them. Just how numbers are represented in different languages is like an entire field of study that you could spend tons of time reading into. Things like randomness. And that's, dude, look, if you wanted to fall down a rabbit hole, dude, check out randomness and how computers do random, how you can never actually have anything random on a computer. Mind bending stuff. It's great. So, yeah, if you're interested in that level of it, you can get to those things from here. We're not going to get that deep into it, but, you know, I'm not sure it would really help you, though. That's the thing. It depends. If that helps inspire you to keep going, but you don't need to know that to use it. You know what I mean?
Yeah, yeah, just kind of like that general curiosity of like,
Yeah.
because like I feel a lot of engineers, they know how to code, but they just don't know like the origins of how, if they were to create a language from scratch themselves.
Yeah, yeah, yeah. And that's the thing. So, like you can do, I know for sure you can like, write your own operating system and stuff like that. You can make your own language. And if you want exercise, like you can write directly in, those bottom languages that we have listed. So we got this, what do we got here? Assembly languages, the very bottom one. You can write, it's horrible. Like, it's just like letters and numbers and stuff like that, but you can do it. You can learn how to read and write that. And these are all just sort of extrapolations on top of that somehow, right? So yeah, you absolutely can. And those are all fun rabbit holes. So I mean, it's like as soon as you find that this is really principles over and over again, right? It doesn't matter what it is, what it's written in. It's going to be documents. It's going to be in directories. It's going to be files. That's it. So
Okay, yeah. Because I feel like the whole base is there, and now people are just keep on adding it to the point where people don't know where that base started from.
right, and that's the thing is we code, and then you see all these languages. You're like, well, what do I like? How do I choose and what do I do? Because all these things do have a slightly different purpose. You know, it started like, what is your trying? And that's the confusing part for it. It's like, well, what, right?
Right.
And it's even a little bit tricky because like it does so many goddamn things. Like you use it all over the place. I mean, you can use it in machine learning, you can use it in data science, you can use it in web development. It's like all over, right? So that's why I really want you to focus on like the patterns and things, right? So like loops and iterations and stuff that we talk about in the last class. It's good to watch that stuff. If you get the hands-on part, cool. But really the concepts are the piece we want to say, and then we're going to start doing the why and build up thing, and you'll see it more in action. We'll use all these data types we talked about, like the lists and all that stuff, and make some classes and actually use them for something. And it'll make it more concrete, hopefully.
Okay. And I think this is a very, very simple question, it's more away from the like conceptual stuff, but like, what's your opinion on Khan Academy's like Python courses?
Oh no,
Are they-
dude, I love them, man. Yeah, yeah. Khan
Okay.
Academy's great. Yeah, absolutely. They're listed in here actually, right
Oh,
here.
sweet.
Yeah, I say do it, man. They got free. They got really good computing stuff, web development stuff, math. Again, like so for me, I ran into a point at which I wanted to learn more math because I was like, fuck, how do I like what are the sets, and I started matrix operations and all that kind of stuff. Khan is great for those sorts of things. It's literally teaching like linear algebra. Again, I highlighted it here. If you want to get into machine learning, it's necessary, but you're going to find yourself wanting to know some machine learning or some linear algebra if you haven't studied it already. So, dude, yeah, Khan Academy is great.
Yeah, because like I'm a political science major that's graduating in the spring, and I feel like I really want to do a pivot. So like I'm always
Yeah,
so deep into this major that I'm about to get the major.
Yeah.
So, but I already know like, okay, I'm not gonna do anything with this.
Dude, so check this. Political science major, bro. Check out. I just recently hooked up with a group called Political Computer Science at Berkeley. You heard of them?
No, I have not.
Do you know a vet named Sebastian?
I think I think he was at the last meeting. I think
Yeah, so
his name's been floating around.
yeah, so he's definitely in this group because I talked to these people. So like they're gonna start partnering with us at Higher Labs doing some stuff that we do, because they're all about, again, it's like political science majors and computer science majors in this group, and every semester they like work on projects that are of some sort of social impact or something, policy, like where policy meets tech. That might be a good place for you to like connect with people and see what they're up to, dude. Because
Yeah, I feel like because I'm taking a course right now that's a political science course, but we're using a lot of R Studio to analyze the data.
yeah,
And I was like, what the hell? I have no coding knowledge. Like, and it's kind of like babying us through it. And I'm
yep,
just kind of like, they write the syntax and I just copy it, but I'm not really kind of like learning how to do the
yeah.
syntax.
Yeah, yeah, and that's and I'll keep saying it too, like, because as we go through next week, like documentation will be there for everything. There's no shame in copying. Again, copy and paste all day long, but just read and really try to understand. Right? Don't kick yourself for not being able to produce the stuff off the top of your head. That's really not as important as reading and understanding and knowing where to find it. Because copying and making small changes, that's like 90% of what developers are doing. That's finding somebody else's code, straight up copying it. I'll show you where and how, like to get it from GitHub, and then they just change it a little bit to their own needs. That's like just that's most of the job, really. So
Hmm.
so don't feel like, oh man, I'm a sham because I'm not sitting down and just with classical music playing in a giant fucking marble room and just spitting this off the top of my head. Like nobody's doing that. We're all knee deep in documentation, writing one line at a time slowly and cursing ourselves for not knowing how to do it better. That's just like that's what you're gonna do. So I'm glad.
Appreciate it.
Yeah,
Appreciate all
man.
the resources.
Yeah, dude, for sure, for sure. Reach out with questions along the way if you got any, man. I'll see you around.
Okay, and I'll probably ask Louise about like connecting with Sebastian.
Yeah, I'm actually. Are you going out to? Here, hold on. Let me stop this recording. Um,